Hi there, and welcome to Balancing Chemical Equations. So we're going to look at what a balanced chemical equation is, what the purpose of a balanced equation is, and what do we use and where when balancing equations. So just to kind of answer the purpose question before we get started, the purpose of balancing equations is to ultimately show the conservation of mass when a reaction is taking place. So we do this in the most simplest form through a chemical equation. So here we've got a sample problem. We've got N2 reacting with H2 to form NH3. So we've got some reactants and we've got some products here as well. So if we take a look here, our reactants and our products don't match in number. So what we need to do is we need to add what we call coefficients. So we need to add a number out in front to make the numbers the same on the reactant side as on the product side. So what I like to do is to start by making a list of the elements that I have in my reaction. So I've got nitrogen and hydrogen. And then I like to make a tally. So I like to keep track of my reactants on the left side of this list and keep track of how many products I have on the right side. So here I've got 2 nitrogens and 2 hydrogens. On the right side I have 1 nitrogen and 3 hydrogens. So we can see that I don't have any matching that's taking place yet. So what I can do is just go down the list. So we'll start with nitrogen here. I've got 2 on the left, I've got 1 on the right, so I can multiply NH3 and multiply the entire formula by 2. That's going to change how many of each nitrogen and hydrogen I have. So 2 times 1 nitrogen, because these coefficients act as a multiplier, is 2. And then 2 times 3 gives me 6 hydrogens. So my nitrogens now are fixed. However, my hydrogens need to be adjusted. So I can come over here and go, okay, what times 2 is going to give me 6? So 3 times 2 would give me that 6. So there we go. First one's balanced. Another example here. We've got calcium, carbon, and oxygen. So again, we're doing a tally of what we have in our reactants. 1 calcium, 1 carbon, 3 oxygen. On the right side, 1 calcium. We've got an oxygen here. There's a plus sign. There's more oxygen on this other substance. So I need to add those together. So 2 and 1 is 3 oxygen. And then I have 1 carbon. So if we look at this, we've got 1 of each calcium, 1 of each carbon, and 3 oxygens. So we're good. We're balanced. And a quick note here. You'll notice that I didn't put any coefficients in front of any of these formulas. So when I have 1 as my coefficient, I would say it's optional to write those in. Typically, we're going to leave those blank to assume to be 1. So chemists like to take shortcuts and not write as much if necessary. So moving along, another example, I've got selenium and oxygen in this one. I've got 1 selenium, 2 oxygen in my reactants, 1 selenium, 3 oxygen in my products. So selenium's good, but oxygen needs fixed. So looking at this, I've got an even amount on the left side, I've got an odd amount on the right. So I'm always going to end up with an even number on the left, or my reactants, so I might as well multiply my products, or at least double it, so increase the number of products I have. Fix here. So I'm going to double this to basically make my odd number of oxygens even. And it does adjust both selenium and oxygen. So 3 times 2 gives me 6 of the oxygens. 2 times 1 gives me 2 selenium. So then my oxygens can be fixed. What times 2 give me 6, and that'd be 3. So I've got 6 oxygens now. So now I just need to fix selenium, and what times 1 gives me 2? It's 2. Alright, the next question, or next problem I have, I've got 3 elements involved in this equation, carbon, hydrogen, and oxygen. Making a quick tally of what I have: 2 carbon, 4 hydrogen, 2 oxygen on the left, 1 carbon, 3 oxygen, 2 here, 1 here is 3 oxygen on the right, and 2 hydrogens. So just working my way down the list, multiply CO2 by 2, it adjusts both carbon and oxygen. So I've got 2 carbons now, and 2 times 2 oxygens is 4, plus 1 more would give you 5 oxygens. Alright, so carbon's fixed, now I need to fix hydrogen, so I've got 4 on the left, 2 on the right, so 2 times 2 would give me 4, but I'm also adjusting my oxygens again, so 2 times 2 from CO2 gives me 4 oxygens, and then 2 times 1 from water gives me 2 oxygens there, so I have 4, 5, 6 oxygens on the right. So carbon's good, hydrogen's good, now I just need to fix oxygen. So again, what times 2 is going to give me 6, and that would be 3. Sometimes with these combustion reactions, if we have an odd number of carbons or an odd number of oxygens on the right side, you'll notice that you're always going to be multiplying by 2 on the left, so it might be helpful to double your initial starting hydrocarbon. So you want to be careful with these combustion reactions. Sometimes we can get numbers that are huge in these, depending on what our hydrocarbon is that's leading the equation off. So just a heads up. If it looks like they're scary numbers, just keep working at it. If you end up with really big numbers, just go back and double check to make sure you end up with the same number of substances on the reactant side as the product side. And then as long as the coefficients don't reduce, because that's another thing we'll have to keep track of, we need to make sure we reduce these coefficients if they will reduce. I've got 1, 3, 2, 2, which won't reduce, but if it had been 2, 6, 4, 4, then I could have divided them all by 2. So I want to make sure I reduce if it's available or an option. Alright, so the next one I have here, I've got zinc, I've got silver, and you have a couple options with the polyatomics. So NO3 is polyatomic. You can either keep it as NO3 if it's the same on both sides, which it is, which I like to do, or it'll still balance out if you separate these out. So you can do nitrogen separate from oxygen and still work out. I like to have as few items here as possible. So doing my initial count, I've got 1 of each on the left, and I've got 1 zinc, 1 silver, and 2 nitrates on the right. So the only thing I have that needs adjusting to start with is the nitrate. So 2 times 1 gives me 2 nitrates, and my silver gets adjusted as well. So then I need to come back over to the right side, and 2 times 1 gives me 2 silver. So that balances us out as coefficients 1, 2, 1, 2. Alright, let's do one last example. Alright, here I've got 4 substances, or at least I'm going to treat my NO3, my polyatomic, as a single substance again. Alright, so doing a count, 1 lead, 2 nitrate, 1 sodium, 1 chlorine, or chloride. I've got 1 lead, 1 nitrate, 1 sodium, 2 chloride on the right. So I guess I can start with the nitrate here. I'm going to have to multiply this by 2 to get the right number of nitrates on both sides. My sodium gets adjusted as well, so then I can come back over to this side to fix my sodium, which also fixes my chlorine. So, thanks for listening.